Got another short chapter today, network troubleshooting. So basically just to remind everyone, wrapping up pretty quick with the lectures. 20 chapters in the book. We've done the bulk of them already, which is probably a good thing for us. So we're going to go kind of quickly through this. There's not a ton of new material in here. Talk about how we narrowed down the problem briefly. Go into troubleshooting steps and troubleshooting tips. So before I begin, I got a question for you all. Okay? So, what do you call a turkey with no feathers? Okay, you guys ready for this one? Thanksgiving dinner. All right. So, first thing you want to do, you got a problem. You got to figure out what the problem is. So, first, talk, see what are the symptoms. What's going on. Think about possible causes. This is an important one. How many devices are affected? Okay. If you don't know how many devices are affected, you're not going to have a very great time at prioritizing and triaging. Okay. You're in IT. You have to prioritize things appropriately. Okay. You have a problem that affects one person. You have a problem that affects everyone. Ceteris paribus. Which problem should you attack first? Everyone. Why? Exactly. Okay. So you have to triage. You have to prioritize. You can't do everything at once. Okay. Maybe you can, and you're a lot better than me. Okay. But think about what is being affected. This is common sense, but if you have devices that are on a wireless network that can't connect, what do you think the issue may relate to? So it's a widespread issue. It's probably something with the wireless network. Could it be something with a radius server? Could it be something with AD? Yeah, it could. Okay? So you got to figure out what the symptoms are, go from there. This is an important one. Recent changes. Okay? Let's say you rolled out some changes over the weekend. Come in Monday, nothing's working. Okay? You think it was a power outage or you think it was the changes that you just made? Probably the changes you just made, right? Okay, you probably made a mistake. Think about what you did, look at it very closely, and lastly, look at the log files. Okay, so that's all you get from this class today. Make sure you understand this. All right, let's go a little bit more in depth. Okay, you got a problem, you've sort of isolated everything. Start with the simplest solutions first. Why do you not start with the most complex solutions first? Okay. So it's going to be time-consuming maybe. Maybe you roll out a change that didn't resolve it, and it's a complex change. Maybe it broke other stuff. Okay? That happens all the time. So, think about a user error. Okay? I've had user errors before. It's certainly fixed user errors for many, many people over the years. Okay? It's a very likely cause of problems. Have someone who maybe isn't the most technologically skilled or not familiar with the system or whatever the case is. They're not using the system to its fullest potential. Let's just say that. Okay? So, let's say that someone is reporting they can't turn on their computer. It's just a black screen. What would you try? Well, you could start with that, but I'd first, maybe start with something a little bit more basic than that even. What would you start with? Yeah, and I'd ask them, what are you pressing the power button on? Sometimes you have to describe a monitor to people. Sometimes people don't know what a monitor is. Hopefully not in this class, but I was having the exam in one of my sections of 223, and I said, make sure you turn off your monitors. Okay, and I had one person who didn't know what a monitor was, and I'm like, well, golly, how'd you make it this far? But that's another story. I had to tell them, this is a monitor. I had to explain all that. Link lights. Okay, let's say you're having no network connectivity in a building. What's the first thing you might want to walk in and check? So you walk into the network closet. It's got all the routers and switches for the building in there. What are you going to look at? Why not check the link lights? See if they're turned on. See if they're flashing. See if they're a strange color. Let's say they're normally green or some sort of like neon, and you walk in and they're amber. Could that indicate a potential problem? Yeah. Let's say they're all off. What are you going to check? Power. Exactly right. Okay. So how do you check the power? You gonna grab a multimeter and test the outlet? Can. Is that the safest and best way? Probably not. Why not just plug something into the outlet, see if it comes on? Your equipment's already off anyway. You're not losing anything to unplug it, plug it in. Now let's say you have no power in the outlet. What else are you going to check after that? Well, if it's, an outlet on the wall, yeah, you go to a breaker. Most likely, though, it's going to be on some sort of like PDU or AP or, UPS or something like that, though, right? So you check the power on those, okay? And maybe it's just a bad outlet on those. Outlets certainly aren't infallible, are they? I mean, they can certainly go bad. I'm not saying it's the most likely thing that happened, but it's something that could occur. Maybe you check the breaker if, that's all good. And, change the outlets around. Now, hopefully, you're in a decent company, and assuming it's not just like some random building, like it's a sort of central distribution point, they probably have redundant circuits, do they not? And it's even not uncommon for companies and, large enterprise buildings or just large commercial buildings in general, I wouldn't say enterprise, to have a separate circuit for their desktop computers, okay? A lot of reasons for that. Think about something like a vacuum, okay? Like a literal vacuum that you run across the carpet. Could that potentially have interference on the power system? It's possible. I'm not saying it's likely, but I'm saying it's possible. And, let's face it, you have a room like this, okay? Are you going to have dedicated circuits to support all this equipment? Yeah. And you can't run 30 desktop computers and 30 monitors and projectors, and you can't run all that on a single standard circuit, can you? If you can, what's likely to happen? Likely to overload sometimes? I think it probably would. Okay, I'm not an electrician by any stretch, but, I know not to run everything, this much equipment on a single circuit. All right, verify power, verify physical connection. Okay, so, let's say you have power in the outlet, but no power to the piece of hardware. Well, maybe the connections come loose. Plug it in. Okay, then lastly, check your privilege. Okay, now we're going to ignore the jokes that I could make there. We're actually not going to ignore them too much, though. Imagine this were a sociology class or something. It'd be a very different meaning, would it not? Okay, what kind of privilege am I talking about? Okay, I'm talking about file privilege, making sure you have the access rights to do what you need to do. So, let's say you're on a Linux server, and you can't access a file, and that's your problem. What you gonna do? You're gonna chmod 666, right? If you're feeling lucky, you could chmod 777. I would personally stick to 666, so it's not a complete ownership, but you do you. Okay, you're on Windows, right-click on the file, see what the rights are associated with it. Okay, so I don't expect any of you to forget this one. All right, talk about some cable issues. We've talked about this a good bit. Yeah, the basic level is just test the cable. I think that's going to really tell you what the problem is. It's going to tell you if the cable's in spec, assuming you have a good cable tester, which you're working for a big company, that's your job to do. You should have a good cable tester, should you not? Okay. It's going to tell you if it's damaged, if it's out of spec, if it has a bad pinout. That'll all be told to you by the cable tester. Now, it's not the only problems you can have related to a cable, though, is it? Okay. So let's say you have a port that has damage. Okay. How can you tell a port has damage? What are some ways we can tell that? tell me one way we can tell if the port has damage. You guys know what a port is, right? So standard RJ45 jack. How can we tell if it has damage? So we can see the pins, right? So how can we tell if they're damaged? Physical inspection, okay? Look very closely at the port, see if it has maybe a bent pin, see if it has a missing pin. These are not uncommon problems. I would say especially in an environment where people are going to be maybe a little bit bored during a lecture, in a lecture hall. You think that some of those ports in some of the classrooms that have them, you think some of those have some damage? I think they probably do. So you have to physically inspect that. What's another way? Can you test it with a known good cable? Yeah. Isolate the problem. Okay. Crosstalk, you should be able to tell from the cable tester. Crosstalk, of course, being EMI interference most of the time, where the cable is not properly insulated, so it's not shielded and insulated against interference from EMI, and it's run in a place that would be subject to EMI. So, for instance, if we were to run non-insulated cable through this ceiling here, you think it might have some issues with crosstalk. Why? Yeah, got a bunch of fluorescent lights. Okay, why else? Could there be other cables up here? Could that cause crosstalk? It could. I mean, I'm not exactly going to get on a ladder and check, but, I imagine there's probably other cables up there. All right, so how do we avoid it? Do we use the right type of cable? Could we use fiber optic cable and avoid it completely? Yeah. How else can we avoid it? Let's say for whatever reason we only had unshielded cable. How can we avoid it? Could we stick the cable in firewall? Yeah. Now, will that completely avoid it? No, but it will reduce it, will it not? Yeah, it should reduce it, especially if you get good firewall. And of course, when I'm talking about firewall, in this context, I'm talking about it's like a conduit-like material where it's kind of like this, and it's got some crease stuff in it. You guys know what I'm talking about? Cable firewall. Not to be confused with like a network firewall, obviously. What's another advantage of firewall, by the way? Yeah, so if the building catches on fire, this should, in theory, protect your cable from melting. And if your cable melts, what's likely to happen? Is it likely to act as a fire spreader, for lack of a better term? Probably. Even plenum cable can certainly catch on fire at the right temperature. You guys know what I mean? Okay. Latency, again, that'll be told to you by the cable tester. So that's basic stuff about cable. Now let's talk about fiber. Okay. So we know that fiber is going to be something that's using light to transmit a signal. So if it's using light to transmit a signal, and we have dirty ends on the cable, or dirty ends in the port for that matter, is the signal going to be degraded? In other words, if I were to shine a flashlight, and I were to put a piece of paper in front of the flashlight, which way would give you more light? Without the paper. Why? Yeah, you're blocking the light with the paper. Okay. Same thing if you got a dirty connector. So, don't ever touch the end of a fiber connector. If you do touch it, what do? Okay, you got to clean it, right? How do you clean it? 90% plus isopropyl alcohol, right? Now, here's a side tip for you. Let's say you're using 90+% isopropyl alcohol for more than 1 or 2 connectors that you're cleaning. Okay, I highly recommend you wear gloves. Okay, why do I recommend that? Dry your skin out quicker than you can say bad joke. Okay, so be careful. I'm not saying you have to wear gloves for it, but I'm saying you'll probably have pretty raw hands if you don't. All right, split cable. Cable tester should tell you this, and if you have a good enough cable tester, it should also tell you approximately where the split is. So, as we know, fiber is a very sensitive cable. It's got a fiber filament in the center, a bunch of insulation stuff, and it can split, With the shielding and everything they put around it, it's unlikely. It's not like you have to treat it, incredibly delicately. I mean, it has a 200-foot pull strength, right? That's better than fishing wire, is it not? Okay. What's the pull strength on fishing wire for most of it? Like 50 or 75, right? I think so. Okay. So it's unlikely to split, but it can split. It's out of spec. Let's say you're running a standard multi-mode fiber run for, 600 feet. Is that out of spec? It can be. Depends on the specifics. In general, what do we want to keep our runs under? 300 feet, right? No. It's always not always possible. So certainly single mode for most part can go far longer. Certainly we could have distribution throughout the building and go far longer. Of course, you can also have a bad port with fiber. Now, how do you test that? Okay. Well, if you're filling, how should I put this nicely? If you're wanting to lose your vision, you could certainly look directly into it and have it shine a light at you. Is that the best way to do things? I hope you don't think that's the best way to do it. Okay. What's a better way? Why not use a port tester? Why not test a known good cable? Okay, there's lots of different ways to ensure that we can make sure the port is working. Does that make sense? So, why can we look into an RJ45 connector, but why do I suggest against looking into a fiber optic connector? Yeah, you can look at electricity, no problem, right? And the electricity going through it, even PoE, isn't going to kill you very likely. I guess it probably could, but it's unlikely. Okay, we're talking like just a handful of watts. You guys know what I mean? Not like a ton of watts. Now, light, okay, you look at it, could potentially blind you. Okay, hopefully you don't want to be blind. All right, wireless issues. We've talked about these a good bit. I'll just go through them kind of quickly. You got interference. How are you going to tell you got interference? Okay, so you may have the symptoms of maybe devices disconnecting, maybe extremely slow connections. And then we look at our wireless controller, we've signed into the access point, however it's configured. And we go to that particular access point, and we see what it's doing. It'll give us, if it's a good enterprise grade device, give us all the different channels and say how occupied they all are. Okay? So that's basically how you identify interference. And let's say you do have interference. What can you do about it? Okay, could you potentially lower the transmission power on all your access points? Could you do that? Should you do that? Maybe. Would you be more inclined to say use the 5 gigahertz exclusively with interference? Would that help? Definitely. What about 6 gigahertz? Would that be even better if your devices support it? Device and bandwidth saturation. Again, you can send on the wireless controller and or access point and see how much bandwidth is being used. Okay, let's say there's a lot of bandwidth being used. What can you do about it? Well, hopefully you can purchase more bandwidth from your ISP, right? Let's say you can't do that. Could you do QoS? Could that help mitigate the problem at least? So is it more important that I'm able to download at 20 megabytes a second? Or is it more important that someone's able to do, maybe a couple kilobits a second of a voice call? Which one's more important? Why? You don't care about my download speed? Well, it's live, and also we're not talking about a lot of bandwidth for the voice call. Even a video call, you're usually talking right around 1 or 2 megabits a second, right? Okay, so if I'm downloading at 20 megabytes a second, that's a lot of bandwidth, isn't it? Okay. So how can we fix that? You gonna throttle me? I want to download my Linux ISOs fast. What about it? What would you do? Then what would you do? Okay. Well, luckily for you, I'm not going to take points off for you saying that, but that's the right answer. You'd have to have quality of service policies in place and stuff that's going to use a small amount of bandwidth, but that's going to need a lot of bandwidth, or not a lot, but it's going to need consistent bandwidth, I should say. You'd put that at the top. Big downloads, at the end of the day, does it matter if my download finishes in 5 minutes or 4 minutes? Does that matter? Who cares if my download finishes in 5 minutes instead of 4? Does anyone care? Well, I care, but not that much, right? I think I'd be a lot more frustrated if the office phones didn't allow me to speak. If it was a garbled mess, wouldn't that be a lot more frustrating? So, QoS will fix this for the most part. Configuration. Now, this could be a multitude of problems. You have it configured poorly, or whatever, that could certainly cause issues. Roll out a bad configuration. Maybe no one can connect at all. Okay, and then the last one, old device. Now, what I mean by that is a device that doesn't support the modern wireless standards. So, for instance, let's say you're a retro computer collector, and you're collecting a lot of retro devices. Okay, and you're wanting to use them on a wireless network just for local stuff. You're not trying to get them out on the internet or anything, just local network communication. Okay, so circa like right around 2000. What wireless card are they likely to have? Is it likely to be a B? It is, right? Could it be an A? Sure, could. But it's likely to be a B. What's the speed of B? It's 11 megabits per second theoretical speed, right? So you're looking at a real-world speed of like 5 megabits a second. Now, let's say you have one SSID, and it has to support the B wireless standard. That's going to bog down everything quite a bit, is it not? Okay. So, what could you do about it? Number one, don't put old devices on a wireless network. A lot of reasons for it. You got security, you got the network performance, you have, well, those are the main two. Okay, the third one is, do you want to pay money to support 20-year-old devices if you're an enterprise? Probably you don't, okay? So that's certainly one issue we may see. Okay, you got old devices, they're bogging down the network but making it use old standards. Okay, how do you avoid that? Well, it goes back to the configuration of the access point, right? You can reject different clients. You can reject them based on the wireless standards. So if they only support, say, A, B, or G, you can choose not to let them on your network. Now, if you were so inclined, you could just literally disable the 2.4 gigahertz radios altogether, could you not? Sure, you can. Okay? And you could force everyone onto 5 gigahertz. That would probably be an overall better experience. Okay, if you're a company, what are you most likely doing with the equipment? Are you most likely keeping it for 10 or 20 years, or are you most likely cycling it every 3 to 6 years? Cycling every 3 to 6 years. You're probably purchasing most of it on lease, and, a lot of tax reasons to do so. It's not a tax class, but, leased equipment in general allows you to write off a lot of stuff. Now, let's say you believe that equipment should last 6 years. Would it make sense to lease stuff for 6 years? I think at that point you probably wouldn't see a huge advantage from it. You'd probably start to see some disadvantages. Could you make an argument that equipment should last 6 years? With the modern IPC and other performance gains we're seeing. Could you make that argument? Sure. I think so. Especially if you're buying good equipment. Now, if you're buying the bottom of the barrel, whatever the bottom of the barrel is nowadays, back in the day it used to be like an Atom or Pentium thing. I don't think they really make either of those lines anymore. But, if you buy the bottom of the barrel stuff, it's not going to last as long. Okay? That makes sense. So, I would suggest that on your access point, that you don't allow devices that don't support A, B, or G, and consider not supporting N. Because when was AC, commonplace? 2015, right? So that's 6 years ago now, right? So why would you be letting devices on that are older than 6 years anyway? Why should we? It's going to slow down everyone else, right? Why not kick them to the curb and say, get a new device? Or, maybe get a new wireless card. Is there a good reason to not do that? Especially if it's company-owned devices anyway, I think that goes without saying. Identify the problem, okay? So there's a little bit more details about this. You got to meet with people. You got to see what their symptoms are, okay? You get the symptoms, try to duplicate it. Go to different computers. Do the same thing they did. See if it happens on their computer, on a different device. Try to see if you can get the problem to reoccur, okay? If you can't get the problem to reoccur, what is it most likely? Is it most likely hardware at that point, or is it most likely either software or user error? It's most likely either software or user error. Now, you'll have to look at the specific symptoms there. Think about what may change it. So there's changes that were recently made. Think about those. Think about what could cause the problem. And then start changing one thing at a time. Okay, you start changing too much at a time, you may not know what actually corrected the problem. You may introduce new problems, okay? So, change one thing and one thing at a time. All right? And then once you've done that, think about what's causing it. So based on your evidence, you're going to have lots of different things it could be. So, for instance, you got one device that has no internet connectivity on it. What could it be? It could be the port, it could be the cable, it could be a software problem with a computer, it could be the computer's network interface card, it could be a configuration problem on that particular port. I mean, there could be a multitude of different things, right? Start testing the most simple one, do one at a time. Hey, if it resolves it, you're good. If it doesn't resolve it, try something else. Okay, this is not exactly the toughest thing ever. Okay? I said start simple and small, triage, think about your software, how it's configured. Again, don't rule out physical connections. Okay, physical connections have problems sometimes, they're not infallible. It's gonna be pretty reliable overall. Think about cable problems, and lastly, don't rule out malware. Okay, can malware cause issues with network connectivity? Sure. So it could be a DDoS attack, it could be a botnet. It could be a malware that straight up disables the network interface card. Maybe it is ransomware that, for whatever reason, it chose to encrypt the network interface card driver. There could be a lot of different causes that are malware related. Now, is that the first thing you should check? Probably not, because is it more likely for some of these others? Probably more likely some of these others. All right. Like I said, it's a shorter class today. Just kind of wrap things up. We talked about how we narrow down a problem, talked about some basic troubleshooting steps, and just some various associated tips. Any questions? All right, Wednesday is the last lecture. After that, it's just lab days from here on out. So, no other questions? See you all Wednesday. Have a great day.